Hello, physics people. It's Mr. Kozer here to see you once again. Say it's Monday. I hope you're doing okay. I don't know if you're counting, but we're getting down there. We don't have too many weeks left. I hope that's okay. We're making progress. Hey, let's think just a little bit about what happened last week, and then we've got one last topic to deal with in this chapter 4 stuff. So one idea, simple machines. That's really where we focused last week. And we thought about the idea that they simply do one thing, right? They make work easier. That is all simple machines do. Now, of course, they do it in a bunch of different ways and a bunch of different things to learn about, but we know in general that's what simple machines do. So one of the questions is, how do we measure how much easier? And that's probably familiar by now as well. And the answer to that question, of course, that's a question mark, is mechanical advantage. So we've been learning about measuring how many times they multiply force. And then we followed that question up with what's the trade-off? Like, are there any things that have to give if you're going to have it have more force output for you? And of course, we really came up with two things here. One of them certainly is distance. In order to have a bigger force, you have to pull with a lot more distance. That is, the force to get bigger requires you to pull for more distance. But the key was energy. And I wanted you to remember that last week we were thinking about energy. And we observed that the input energy you put into a machine is always more than the energy you get out. And that, of course, led us to this idea called efficiency and the way we measure how much of the energy that goes in becomes useful. And we've worked a little bit around this, where here we look at, of all the work you put into a system, you don't get it all out again. And the question is, how much do you get out? And of course, the percentage work in over work out is this new idea called efficiency. So that's where we've been. That's the basic key ideas of last week. Hey, like I said, we have one new idea this week that I want to share with you. So let me tell you just a little bit about that right now. And then we'll go on with this last topic. The last topic is this. We're going to think about energy and the rate at which we use energy. You're probably familiar with light bulbs and the numbers on top of light bulbs. Let's see. There's one here above my head. I think I'll grab it. If you look at this light bulb, it says right on the side of it, 8.5 watts. Of course, it's an LED bulb. It's pretty efficient because that's how we like to roll around here. But this LED bulb runs with an efficiency that's very high. And it says on the side 8.5 watts. Now the question is, what does that mean? And that's where we're going. 8.5 new unit, folks. Notice it's capitalized. It's a person's name. The unit is watts. And I want to help you to understand what that means. That is a unit that simply says how many joules of energy is something using or converting or transferring, depending how you want to think about it, per second. So this light bulb that draws 8.5 watts simply means that it uses 8.5 joules of energy every second that it's turned on. In other words, every time it's on for a second, 8.5 joules of energy become light and heat, a combination of those two things. Of course, hopefully it's mostly light, but sometimes we get heat as well. So if I turn on this lamp, oh, hello, every second that it's on, let's see, ready, set, on, 1001, off. In that second, 8.5 joules of energy got transferred to light and heat. If I turn it on for 2 seconds, 1001, 1002, well, now it's 17 joules because that's 2 seconds. So the equation is really straightforward. The equation looks like this. Power, that's our new term, power. And on the top is energy. Now you notice that's exhibited or expressed in joules, which is the unit we usually use for energy, but we might also think of that as work because, of course, the way we do give something energy is to do work on it. So power is energy over time is usually how we think about that. Or certainly it's not wrong to think of that as work over time. So pretty straightforward idea. Power is work over time. And of course, as you can imagine, what I'm going to ask you to do is practice with some calculation problems today. Now let's think about this. We can write this three ways. We can write power is work over time. I'm going to use a W here instead of energy. Or we can flip it around. We can solve it for energy or work, and we get work is power times time. Or, of course, we can turn around and solve it for T, time, and get work over power. Now, one of the things I'm going to point out right off the bat that's dangerously confusing is I've just used the letter W to represent work. Yeah, I wrote the letter W to represent work here because as a quantity, W stands for work. But up here where I have a unit that starts with W, the unit is W for watts. So don't let that confuse you that we have work represented with a W, but also the unit for power is represented with a W, and that's watts. So again, if you look at these problems today, I'd encourage you to read through the top. There's a good discussion about the things that we've just talked about together, about finding power. Now you'll notice you need to have the time in seconds. So if you don't have time in seconds, you'll have to adjust that. But take a quick look at this first problem as an example here, and you'll see that we have a motor that does 5,000 joules of work in 20 seconds, and your job is to find out how much power. Oops, I scooched off the page, sorry. So all you're going to do is you're going to take that energy, 5,000 joules, and you're going to divide it by 20 seconds. So again, power, work, or energy over time. Please get in the habit of showing your work. As usual, it helps you know what you're doing. And then if things don't go well, you can certainly use that to tell where you got goofed up. 5,000 divided by 20 seconds. And let's see, 5,000 divided by 20. What do you think? Well, 20 times 5 is 100. And then, boy, what are we going to do with that, huh? Can you figure that out in your head? I'm going to whip out the calculator just to be sure, because, you know, it's not a bad thing to do. 5,000. Boy, I must be rusty. That's 250. And the units on that, of course, for power are watts. So I'm just going to write a capital W. Hey, what I'd like you to do is continue to try those problems today. Again, there are 10 of them. They're fairly quick practice. And that's the story. Stop into office hours. If I can give a help. Check out the answers. Of course, they're posted. And let's take that for a spin and see how it's going. Thanks, folks. I will talk to you soon.